Hi everyone, I hope you're well. I figured I would go through this quiz review worksheet and kind of explain how I'm getting everything and send that out. I got a couple questions on it, so I thought it'd probably be easier to just kind of walk through every problem, explain how I did it, and then you guys could listen to it and get an explanation as well as see the work that I did. Okay, so let's get started. So the first three here we're graphing. Remember when we graph it, whatever's in the parentheses here, that's how we're translating it. So we're going to go right 2, I'm using shorthand here, up 3, right, plus 3. So right 2 because it's x minus 2, plus 3, up 3, and then that 3 on the outside is a vertical dilation of 3. Okay, so that comes from here. So I'm going to go from 0, 0. I'm going to go right 2, up 1, 2, 3, and I'm going to plot my vertex. Notice that's a positive 3, so my parabola should open upwards, and I can make kind of a table here for drawing that. We're going to make an over and up table, and I'll just do O and U for over and up. The normal rule is 1, 1 and 2, 4, but since we have a vertical dilation of 3, I'm going to multiply my ups by 3. Okay, so from here I'm going over 1, up 3, and over 2, up 12. And I'm just counting it out there to make sure I get the right points, right? And then be sure to draw in a curve that looks like a parabola. All right, so there's your parabola. Like I said, your vertex is right here. That point is 2, 3. Hopefully you guys remember domain and range for a parabola. Domain is always negative infinity to infinity, or you can say all real numbers. Range, since it's opening up, our lowest point, which is here at 3, is going to be with the bracket, and then it's going up forever, so it's going towards infinity. We have an axis of symmetry that goes down the middle here, so that's x equals 2. And then I got a question regarding average rate of change. Remember, for average rate of change, you make a slope triangle between those points. So from 1, that's when x is 1 on the graph, to x is 4, to x is 4, that's up here, right? So we're making a slope triangle between those 2 points because those are the 2 points when x is 1 and when x is 4. So I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9 over 1, 2, 3. So 9 over 3, right? And then you want to reduce that fraction to get 3. Great, let's try this next one. So that negative out front means it's been reflected over the x-axis. So it's going to be upside down. This 2 is a vertical dilation of 2. And you didn't have to write this out. I'm just writing it out. Plus 2, that's left 2, up 1. Okay, so I'm going to plot my vertex first by going left 2 and up 1. We said it was reflected over the x-axis, meaning it's upside down. And then it has a vertical dilation of 2, so we're going over 1, down 2 from that spot, right? And over 2, down 2, 4, 6, 8. All right, so there's our quadratic. That point we plotted to start, that's our vertex at negative 2, 1. Our range, it's opening down, so it's not going to infinity this time, it's going towards negative infinity. And our highest point is 1, right? And we use a bracket there. We can see our y-intercept right here. It's where it crosses the y-axis. That point is 0, negative 7. we know it's opening down. We can see that pretty easily. And the interval where it's decreasing. Remember with decreasing, that's where as you look at it from left to right, where is the graph going down? Right? So as I read this from left to right, if I were to trace with my pencil, it's going up to -2, and then it's decreasing here, right, on this interval right here. So that's when x is from -2 to infinity. All right, next one. Again, we're going to graph it. It has a vertical dilation of 1/2. That's that 1/2 out front. Left 4, down 2. Okay? So I'm going to go left 4, down 2, and plot my vertex. Then it has that vertical dilation of 1/2. So instead of the normal 1, 1, 2, 4, we're going to multiply this up amount by 1/2, right? And I ran out of space there, so I'll write it down here. I get 1, 1/2, 2, 2. So over 1 up 1/2 on both sides, over 2 up 2 on both sides. Great. This first point we plotted right here is our vertex, -4, -2. Our axis of symmetry, we know goes down the middle, and we always state it as x equals -4. For our average rate of change, remember we find the x value at -5, that point's right here. The x value at -2 is right here, and I'm going to make a slope triangle between those 2 points. So from here, I'm going up 1.5 and over 1, 2, 3. So it's a rise of 1.5 over 3. If I reduce that fraction, I get 1/2, right? And then the interval where it's increasing, well, that's where it's going up from left to right. So that's this part right here. The other side is going down because it's as if I was tracing my pencil as I look at the graph from left to right. Right, so where I colored that yellow is from -4 to infinity. Great. All right, let's keep going with these. So next, write an equation for a quadratic function that has been dilated by a factor of 7, reflected across the x-axis, and write 23. So I can say f of x, that reflection across the x-axis is a negative out front, dilation of 7, that's also out front, and then write 23 we express with x minus 23 squared. Okay, write an equation for a quadratic function that has been dilated by a factor of 1/2. So that, again, that dilation's that first number that we're drawing right here. Left 6, so left is plus, right? It's the opposite of what you'd think. Down 8. All right, then describe the transformations from the quadratic. So here, we're given 3 graphs. We're going to describe what's happening and then write an equation. So remember, from 0, 0, how are we getting to our vertex? Well, from here, I'm going over 1, 2, 3, 4 to the left, so translated left 4. This point came down 1, so it's also translated down 1. And I said order matters. You always do reflections and dilations first. Now it's opening up, so there hasn't been a dilation, but from this point to my next point, I'm going up 1, 2 over 1. So this has a vertical dilation of 2, right? So if I were to write that out as an equation, I'd have y equals vertical dilation 2, x plus 4 squared minus 1. Okay, let's try this next one. Well, first thing I notice when I look at this is it's upside down. So if it's upside down, it's been reflected over the x-axis. my vertex is right here. So I can see that it's been translated right 4, but I'm going to leave some space because I also can tell there's a dilation. Haven't counted it yet. So translated right 4, and then down 2, right? And then from here to the next point that this quadratic goes through is right there. So I'm going down 1, 2, 3 over 1. So this has a vertical dilation of 3. If I take that all and put it into equation form, I get y equals negative for the reflection, 3 for the dilation, x minus 4 squared minus 2. All right, last one. Let's look at this. So it's upside down again, so we know that it's been reflected over the x-axis. I can see there's a dilation, so my vertex is right here, right? So it's been translated right 4 and up 4. And then last, from this point, I'm going over 1, down a half. Whoops, over 1, down a half. Right, so this is a vertical dilation of a half. So y equals negative 1/2 x minus 4 squared plus 4. Great. Well, hopefully this helps a little bit. If you have more questions, please feel free to email me. Try to check tonight and then like first thing in the morning before your quiz. So let me know. Great. Thanks.